All right, in the previous videos, we were looking at position versus time graphs. These are velocity versus time graphs, and they're slightly different. You can see how they're labeled with the units. But let's go back to the first example we saw before. We have a spot, and we have somebody standing a certain distance away from that spot. And let's say they're just standing there and they're not doing anything at all. Before we measured their position as time passed, now let's measure their velocity as time passes. So if they're not moving, their velocity at time 0 is just 0. They're just sitting there, so their velocity is 0. So we would plot and we'd put a number here. And 1 second later, if they're still just standing there not moving, their velocity will still be 0. And if they're still not moving and still not moving, their velocity will continue to be 0. So anyone who's standing perfectly still, their velocity graph is going to look something like this, which may make you think it's just like a position graph, because notice this is a flat line and they're not moving, but it's not quite the same, and let's see why in a second. So back to here, let's say here's our origin where we're measuring from, and now let's say the person is not standing still, but they're moving, and they're moving at a constant speed to the right. So that means every second we check in with them and we see how they're moving. It's almost like looking at their speedometer and just seeing what is on their speedometer every second. So let's say at the beginning, they're moving 1 meter per second. So they're moving to the right at 1 meter per second. They have, like one of those, they have a speedometer on them, like a Fitbit or something that can measure this. So 1 second later, we look and they're moving the same speed. And another second later, they're moving the same speed. So what this would look like on the graph is this. It's also a flat line. But whereas on a position versus time graph, a flat line meant somebody wasn't moving or they were in a constant position, here a flat line on a velocity graph means they're just moving at a constant velocity. In the last example, that constant velocity was 0. They were standing still. But here, they're moving to the right at a constant speed. So a flat line on a velocity graph does not necessarily mean they're not moving. It just means they're moving at a constant speed. In this case, somebody is moving to the right at 1 meter per second at a constant speed of 1 meter per second. If somebody were moving faster, again, that example we did before where somebody's standing here and in 1 second they actually end up here and in another second they end up here, they're moving at 2 meters per second, so their velocity versus time graph would look like this. So the further you are away from 0, the faster you're going. This person is moving 2 meters per second. This person is moving 1 meter per second. All right, the last thing about the velocity versus time is, again, what happens if the person is moving to the left? So if this person is standing here and they're moving left, then their velocity versus time graph, at the beginning, they would have a negative velocity. And if they're moving at the same speed, not changing their speed, it would continue to be -1. They're just ambling along at the same rate. And so you would see something like this. So if your velocity is below 0, if it's negative, that is usually going to indicate that you're moving to the left. So this person here is moving to the left at 1 meter per second. If we had somebody else graph like this, they would be moving to the left at 4 meters per second. And again, they're moving left because their velocity is negative. So you can also have your velocity change, which we're going to get into in a future unit. Right now, we're only talking about constant velocity where you're not really changing. So here, this person's moving to the right at 3 meters per second. So of these three, who's moving the fastest? This person. Even though they're -4, that is a faster speed because 4 is bigger than 3. But this person is moving to the left, whereas this person is moving to the right. Anyway, try this quiz that relates to this, see how it works out. We will come back and practice some more with this. But this is just sort of to get you started on this. So until next time, I am Derek Genova. Have a delightful day.